Hello, eager young minds. Today I'm going to explain the equation of a straight line. No, not an explanation, but it's just going to be a very short derivation. I was wondering whether a separate video is actually required to explain how equation of straight line comes in the first place. But I thought that I would just make this video in case some curious young minds may want to know how the equation of straight lines, how it could have been conceived in the first place. So this is my interpretation. Please feel free to give your comments and give your insights that can be extremely useful to delve deeper into these types of topics. Fine. So to begin with, let me draw a straight line with a set of coordinate axes. So here is our y-axis. All right. This is our x-axis. It's fine. I'm going to draw a straight line. So this is our straight line. Now we are going to find what is the equation of this straight line. Assuming that we don't know the y is equal to mx plus c in the first place, then how do you get to that equation? Okay. Now what you do is, maybe what I can do is I can choose a point, 2 points. Okay. And what I'm going to do is I'm going to drop a perpendicular from this point and drop a horizontal from this point so that they meet here. Maybe I can call this as A, B, C. Obviously BC, this is going to be dy, and this AC is going to be dx. I can define something called as tan theta now. So tan theta, which is the slope, is denoted by the symbol m. M is equal to tan theta, which is opposite side, which is dy, divided by adjacent side, which is dx. I can rearrange this equation to get dy is equal to m into dx. M is just a constant for a particular straight line. M is just going to be a constant. Okay. Now what I'm going to do is I'm just going to integrate this equation. So let me integrate the equation, the above equation. So if I integrate the above equation, then Newton used to put the symbol this way, S this way, which stands for the summation. What do you get if you just integrate? S stands for the summation, which means that it represents all the small dy's if you add them. For example, if you take another point, another 2 points, then your new dx will be this, and your new dy will be this. Maybe if you are taking another 2 points, then this is going to be your dy, and this is going to be your dx. So what is this integral of dy represents? It represents the total dy's. Adding all the dy's, you'll be getting this total y. And what is this integral of summation of dx? Of course, you are hitting it with slope, but summation of dx alone, that would indicate the total x. Okay, I think that is clear. I think that has a physical meaning. So we don't have to get confused when we just put the integral sign. What it actually means is you are just summing it up. That's all. You are summing up all the dy's, and you are summing up all the dx's, right? So Newton was just putting the symbol S in this particular fashion. That's why he came up with this calculus. Newton invented this calculus, but he didn't talk about it to anyone for 27 years. I read it in a book. I think he also invented gravity, and he didn't talk about it to anyone for 10 years. Newton clearly was a very shy and self-effacing person, but he gave a shortcut. He gave a shortcut for integration. There is a separate video on integration that I have made. So if you want, you can check it through at your leisure. Okay. So now if you integrate this, what is that you are going to get? You are going to get y is equal to m is a constant, and if you integrate dx, you are going to get x. We know how we are getting y because it's the total dy's, that is y, and the total dx, and that is x. Of course, when you integrate, that can be a constant that would have disappeared when you had differentiated. When you wanted to go from this step to this step, when you differentiate, differentiation of your constant is going to be a 0 because constant cannot change. All right. Now we know, now this is the equation of the straight line. The only thing that has to be interpreted is, what is the c? That is very simple, quite straightforward, quite axiomatic. All you have to do is substitute at x is equal to 0. So what happens to the value when you put x is equal to 0? What is the point that you get to? Well, the point that you are going to get to is this point. Right at this point, this is the point where x becomes 0. Okay, so that is the point. So when x becomes 0, the value of y becomes equal to c. In other words, c is the value of y when x is 0. At x is equal to 0, what is the value of y? Well, the value of y is this. Okay, so this is called as the y-intercept. All right. So this is the equation of the straight line. This is how it comes. But there is one additional piece of information that I want to give here in the first place. Now, this is the equation of straight line. Perfectly fine. Well, if you want to find the values of the constants, which is m and c, provided if you know two values, say for example, you have got 2 points. Stay tuned. One piece of insight is coming. Let us say that this point is x1, y1, and this point is x2, y2. Well, you can substitute. There are 2 unknowns in this equation. One is m, another one is c. If you want to find the 2 unknowns, if you know these 2 points, treat them as boundary conditions. So the first equation is y1 is equal to m into x1 plus c. This is going to be our first equation. And y2 is equal to m into x2 plus c. This is going to be our second equation. Very simple, guys. All you have to do is solve the 2 equations to get the values of m and c. Everything seems perfectly fine. But there is a point, there is a place where you cannot solve. Now, what is that place? So let me explain that. So let me entail a set of coordinate axes. So here we go. This is our y-axis. This is our x-axis. Now let us do exactly the same. Let me construct a straight line, but this time the straight line would look like this. Okay. Now, what about the equation y is equal to mx plus c? Will it hold good? Let us try this. Y is equal to mx plus c. If you try to solve for, let us say, let me give some examples here. Let us say that this point is 0.5 comma 0. And let us say that, let me consider one more point. Let me say that this point is 0.5 comma 0.5. When you try to substitute the values, let us say that at y is equal to 0, the value of m into x is 0.5 plus c. This can be our first equation. The second equation is when you substitute these 2 points, that is y is 0.5 is equal to m into x is 0.5 plus c. Of course, now the mathematics is breaking down, but just out of curiosity, if you just try to solve these 2 equations, then these 2 terms cancel out. You get minus 0.5 is equal to 0. Clearly, it's a violation of mathematics. Okay. Now, what happened now? Well, we have to go back to the origin now. Let us go back to the origin. The origin is, how did we get this equation? We got this equation from m by defining m, which is dy by dx tan theta. Now you cannot define dy by dx because when you try to define dy by dx for this equation, m becomes infinity because the denominator dx is 0, tends to become 0, so m becomes infinity. So this equation y is equal to mx plus c is valid only when m is less than 90 degree, when the slope is less than 90 degree. Okay, it's not going to be valid for a perfect vertical lines, and even sometimes it's not going to be making sense for a perfect horizontal lines. Okay, so that's the point. And also there is one more point that you have to consider. C always is going to be the y-intercept. Now there is no y-intercept here. There is absolutely no y-intercept here because this equation is cannot interact with the y-axis. So what should be the equation of this line? The equation of this line is very simple. It's just given by, say for example, this is 0.50. So only the value of y-axis is changing, but x always is 0.5. So the equation of the straight line is x is equal to 0.5. Y can be any values. So it's simply x minus 0.5 is equal to 0. So that is the equation of a vertical straight line. So in other words, you just have to say x minus, maybe you can denote this as a constant and just put that equal to 0. Okay, in general terms I'm saying, because only the values of y is changing, and you just have to draw a straight line at x is equal to 0.5. That's the equation of the straight line. So clearly, even that is going to be perfectly true when you draw a horizontal line also. Okay, fine. So these can be some of the insights that you can get by simply trying to look at an equation and don't accept that equation. Okay, y is equal to mx plus c, that's the equation of the straight line. No, it's not going to be the equation of the straight line in all the cases. When the slope tends to become infinity, that equation breaks down. So we have to try to hack the equation from all possible directions and find the domain within which the equation holds good. Thank you so much for your patience.